Good day, guys, and welcome to the Introduction to Programming in C++ first session, part 1 of the Diverse Node Mobility Front-End Development Program. Today, we will be discussing Chapter 1 that talks about the introduction to computer programming. But before we continue to the intro to programming in the proper lesson, I'm going to have an overview about the difference between C language and C++ language. So here I'm going to share my screen to you guys. All right. So the difference between C and C++. So C is a procedural language, while C++ is a non-procedural, and it is a object-oriented language. And C top-down approach is used in program design, while on C++ used bottom-up approach adopted in the program design. And C language has a multiple declaration of global variables are allowed, while in C++ multiple declaration of global variables are not allowed. C requires all the variables to be defined at the starting of the scope, while C++ allows the declaration of the variable anywhere in the scope, maybe at the first on the time of its first use. And in C, the malloc keyword and the calloc keyword functions are used in the memory allocation and the free keyword function for memory deallocating, while in C++, new and delete operators are used for memory allocating and deallocating. So what is the uses of C++ language? So C++ is used by the programmers to develop computer software, and it is used to create general system software. Also, C++ used to build drivers for various computer devices. C++ software for servers and software for specific application, and also C++ used in the creation of video games. How about the advantage of C++? So C++ is relatively low level and is a systems programming language. It is also has a large community, so you can ask a question maybe in the forums about C++, and also it has a relatively clear and mature standard. Also, it uses modularity. C++ also have the reusability and readability. So how about this disadvantage of C++? So it has data is global or local. Also, it emphasis on instructions but not on data. And it can be generally heavy if not careful while coding. And lastly, data is global, and global data does not have security. All right, so now we are going to resume the module. Let us first discuss Module 0, which introduces the IDE and online tools in running the C++ language. All right, so the work environment, creating your work environment, where to begin. Every creative activity needs tools, and programming is no exception. In its simplest form, programming requires a sheet of paper and a pencil. Of course, we are not going to practice programming like this. It would be quite good practice for writing raw code, but it's impossible to run and quite impractical, as running the code is the only method of finding out whether it's correct. Programming requires a computer equipped with some additional tools. In this document, we will show you some ways of using your computer as a developer's workstation. However, don't forget that there are many factors affecting actions that must or must not be performed. Hardware platform, operating system version, and etc. We don't know your system, so our guide is general. We will show you the direction you will have to find solutions yourself. Unfortunately, all of our suggestions require access to the internet, either permanent or temporary. You need to download virtually all installation files from the product site. Other tools work online only. Sorry, there are no workarounds. By the way, you can successfully run all your programs and examples without the use of any specialized environments, only by using standard text editor and command line compiler tools. However, we don't recommend it, and that is why we are going to use some special applications that will able to us to utilize a range of tools in one place. Generally, there are two ways in which we can advise you. First is using local installed IDE, and second is using online tools. So we have discussed these two kinds of tools in our previous lesson. Okay, so this is also works for C++. Okay, so what is IDE? Let us define what is IDE. IDE stands for Integrated Development Environment. Is a software application that typically consists of code editor, a compiler, a debugger, and a graphical user interface builder. Programming within an IDE has many advantages. First, you get a toolkit containing everything you may need, and real programmers usually use an IDE too. An IDE gives you a comfortable desk equipped with all means, supplies, and aids. There are some disadvantages too. Comfortable desks usually weigh a lot, so do IDEs. They may consume a lot of resources, and frankly speaking, you probably don't need most of the function they can perform. Using online tools allows you to write, store, and run your code without installing anything. Imagine it as a simplified IDE accessible remotely via the internet. That means that you need two things, an internet browser and an internet access. If you can try both approaches, then choose the one that's more convenient for you. You can, if you cannot choose the one you can use. Okay, so let us choose your IDE. There are many IDEs on the market, both free and not free. To get a rough idea of how big the list of integrated development environments for the C++ language, you can visit Wikipedia. We wrote and tested all our examples in NetBeans. It doesn't mean that we think NetBeans is the best. It may be that other products are more in line with your tastes and habits, so you don't need to follow our path. Feel free to make your own decisions. However, please be aware that very few of the exercises is this cour- in this course may be preconfigured for NetBeans. For this reason, you need to remember that some practical elements of the course might not work in some other IDEs the way we intended them to work. We want to show you the five sample IDEs. Again, this doesn't mean that we think they are better than the others. They they may be more popular than others, or we do actually like them for various reasons. Here are they. First is the Microsoft Visual Studio Express. So a single platform now, it has been even multi-platform support, development environment designed specially for building C++ programs, both under and for the Microsoft Windows operating system. So you can visit their home site at www.visualstudio.com, and if you are going to download their software, you can, or the IDE, you can choose this link or click this link. All right, so its license is proprietary, but limited free version named in Visual Studio Community is available for free download, and registration is required. All right, so let's talk about Eclipse. So Eclipse is a multi-platform development environment designed specially for Java. So programming possible without additional configuration, dedicated C++ version available for download. So you can visit their home site at eclipse.org, and for downloads, you can check it www.eclipse.org/downloads. All right, so let's have NetBeans. So NetBeans is a multi-platform development environment designed especially for Java. That's C++ programming possible without additional configuration. And their home site is netbeans.org, and you can download their IDE here in this link. So how about code blocks? This is a multi-platform development environment designed for C or C++ programming. Default Windows installer does not include C++ compiler. Use the one containing ming.w, then dash setup inside the file name instead. So code blocks is for Windows, Linux, and Mac OS. How about Xcode? So this is a single platform development program designed specially for building applications for operating system designed by Apple Incorporated, programming in C++ fully available. So you can visit their site at developer.apple.com/xcode. And if you are going to download that, then you can use this link. Unfortunately, we cannot provide any support in the installation and or use of any IDE either for the ones we mentioned and the ones we didn't mention. If you run into problems, seek help from the vendor of your software or recommended from other users of the particular product. There are many available resources, FAQs, forums, help desk, communities, knowledge base, etc. It is unlikely that your problem has not already happened to somebody else, and if it has, it is very likely that it was solved. Search for solution and you will find them. If you are a Linux user, try to use your primary system tools to download and install IDE. If you use any other sort OS, search for a complete native installation package. So I choose NetBeans, and if I'm going to uh, load the NetBeans that apache.org download slash index.html, go to downloads, this updated one. So if I'm going to click this, it will prompt me to the list of downloads here. So if your OS is a Mac OS, then click this one. And if you are using operating system Linux, then choose this one, just click it. And if you're using Windows, then click it. Since I am using Windows, then I'm going to click this one. And right, so here there are lots of um, server to be downloaded of NetBeans, source of NetBeans. So you can choose among them, and for me I choose HTTP. Right, so if I'm going to click this one, then it will prompt me to download, and here I'm downloading that exe file. Right, so I'm going to post this video, and then we will continue later after downloading it. All right, so it is now successfully downloaded. You can click it by running or opening the file, and then we are going to install this. Okay, so let us choose NetBeans since the module talks are configured in NetBeans solution. All right, guys, so it will prompt you to make changes, then say yes. Okay, so all we need to do, if there is no Java SE development kit was not found in your computer, all we need to do is visit the site, the Oracle.com Tech Network Javase, then download. So before we install that Apache NetBeans, we are there is a requirement. So that would be the JDK. Okay, so let us search for JDK. So here guys, so I'm already here at the Oracle downloads, specifically in JDK here. You can see it here. So the updated version for the JDK is 13. So I'm going to download this one here. So it will prompt me to another page here. So it will give me a list of download XE. So for here, since I am using Windows, right, so now it is okay. So now we are going to wait for this file and install it before we all right, we have finished downloading the JDK. I'm going to run this program. Right, we are going to wait for prompting the option for JDK installation. Here, still loading. Here, yes. Do you want to allow this app to make changes to your device? Then say yes. Right, so here we are going to click the next, and then of course it will be always installed in C. Okay, C in the local disk. If you want to change it, if the default is in D or in the desktop, then change it to C. You can push the button here in the change. Okay, so click the next, and then we're going to wait the status of the progress in installing the JDK. Alright guys, sorry for the interruption. It seems like my computer hangs up because of so many apps that I've been running. Alright, so after the couple of minutes in doing the progress installing the JDK, it will prompt you to this if it is completed. And then you can click if you want to access the tutorials, API documentation, and developer guides. But I'm going to show you in our future lesson on how to use the IDE. All right, so going to close this one and let us open or run the NetBeans. So find wherever you have saved the exe file. Okay, so I'm going to click this and then wait for you to start the installation. All right, so as you can see, it's configuring the installer. Let us wait for the installer one start the running. It's all right. So here, welcome to the Apache NetBeans IDE and the current version. For now, it is 11.2. And then you can see that the installer will install the NetBeans IDE with the following packs and runtimes. Click Customize to select the packs and runtime to install. So for now, we are just going to install the recommended uh, installation or the runtime. So just click Next and then accept the terms in the license agreement and then Next. And then here, as you can see, install the Apache NetBeans to IDE. Of course, it will always be C. So choose C file if you want to browse it. Okay, so here in the disk PC and then local disk. Okay, for now, I'm going to cancel this one. Just like here, it will detect that JDK a passionate bean. So since JDK is it is installed in C, then it will prompt you and give you the directory for JDK. So click next and then check the updates, yes, for us to be updated in any of the installation. Right, so let us wait for the progress in installation of the Apache NetBeans IDE. All right, so it is now set up. All right, so I'm going to click finish. All right, so now we already installed the NetBeans IDE. We are going to use that in the future. So just save it, and here, recently added. I'm going to right click this one and just pin it to the taskbar. Here. All right, so here it is now already installed. Right, so let us continue in the next slide. So we are going to talk about online tools, the IDE one. So to get started with the programming, you don't have to install anything. If you're reading this, you have a working internet browser and an active internet connection. This means that you can use one of the sites below and start programming immediately, just like one. So the first one is a tool named IDE1, available at IDE1.com. Although you don't need to register to start your work, which we suggest that you do. It will enable some additional valuable features. Signing up is easy, certainly not more difficult than the registration on the C++ Institute website. You can also use the Facebook account to sign in into IDE1. It will make the whole process even faster and more convenient. After signing in, you will have to do some customizing, and two things are essential. First is change your default programming language to C++, and then enable syntax highlighting. It will make it easier to do your work. And to test the IDE1 environment, go to the new code tab and just copy paste the following text on the source code field. So if you already opened the IDE one environment, you can copy it and then paste, and then next click the IDE1 it button. Then it text saying it's working should appear almost immediately in the std out field. This means that your source code has been happily compiled and run. Easy, right? So but there is one catch, that you are not allowed to send more than 1,000 submissions a month. We don't think that's really going to affect you though. Something important. If your program really reads any data from a user, you will have to prepare the data inside the std in before the code is run. Normally, the process of reading input is interactive. So check the ide1.com/FAQ for more details. All right, so another online tool will be very similar functionality with C++ shell, available at cpp.sh. You don't need to register, and its principal operation is very similar to features as IDE1. It also doesn't include any support. Uh, to tell you the truth, it is so simple to use that you actually don't need any help. Now it's time to start learning in some real programming. So in this module, we are going to use the IDE which we have installed earlier, and that is the NetBeans. So by the way, guys, that if you are using Mac OS, Linux, and Windows, and take note that NetBeans is a multi-platform IDE. So no need to worry, it will run whether your operating system is different. All right, so let's have the introduction to the computer programming. This would be the chapter 1.1. So natural language versus programming language. We are here to show you what the C++ language is and what we can use it for. Let us consider for a moment what language itself is. Not only the C++ language, but any language people use. We will try not to use scientific sounding definitions, and we will try to speak informally. We can say that a language is a tool for expressing and recording human thoughts. We really like this definition. In other words, it is a mechanism known to us and to our partners, allowing us all to understand and to be understood. We use language for speaking, writing, reading, listening, and thinking. At least one language accompanies us throughout our entire lives. It's our native language or our mother tongue, which we learn almost unconsciously from the very beginning. Many of us will learn other languages too, mostly as a result of a conscious decision forced by social conditions or business needs. The languages we use to communicate with other people are called natural languages. They were created over many centuries and still are subject to change. If we ignore that have been created artificially, such as Esperanto or even Kenya, the language used by elves in Tolkien world, their development is almost independent of their speakers and evolves naturally in a way that gives a little to no control over it. However, there are languages whose creation and development were dictated by some specific needs and whose development is fully subject to control by very wide groups of people, like international committees or work groups. The shape of this language is defined by international standards, and although they may be understood by many people, the exchange of thoughts between human beings is not their priorities. Such languages are, among others, programming languages. You are probably familiar with this concept already. A programming language is defined by a certain set of rigid rules, much more inflexible than any natural language. For example, these rules determine which symbols, such as letters, digits, punctuation marks, and so on, could be used in the language. This part of the definition of language is called lexicon. Another set of rules determines the appropriate ways of collating the symbols. This is syntax of the language. We also need to be able to recognize the meaning of every statement expressed in given language, and this is what we call semantics. Any program we write must be error-free in these three ways: lexically, syntactically, and semantically. Otherwise, the program won't run. It will reproduce an acceptable result. You can be sure that you will encounter all of these errors, as the error is human and it is fallible humans who write the computer programs. The expressive power of programming language is much, much weaker than natural languages. We cannot use such a language to express human emotions, and it is hard to imagine a declaration of love encoded inside a programming language. This is because the message embedded inside a computer program is not intended for a human, but for a machine. You might be asking yourself why we need to use a programming language at all. And that's a good question. Let us try to answer it. A computer, even the most technical sophisticated one, is devoid of even a trace of intelligence. You could say that it is like a well trained dog. It responds only to a predetermined set of known commands. And sometimes, like a dog, it just shuts down and refuses to do what it's told. The recognized commands are very simple. We can imagine that that the computer responds to orders like take that number and add to another and save the result. A complete set of well-known commands is called an instruction list, sometimes abbreviated to IL. Different types of computer may vary depending on the size of their ILs, and the instructions themselves can be entirely different in different models. The IL is in fact an alphabet that is commonly known as machine language. This is the simplest and the most primary language we can use to give commands to our computer. We can say it's the computer's mother tongue. Computer programming is an act of composing the selected commands or instruction in an order that will cause a desired effect. The desired itself can be different in every case. It is up to the programmer's intention, imagination, knowledge, and experience. It is possible for a computer program to be coded directly in machine language using elementary instructions or orders. This kind of programming is tedious, time consuming, and highly susceptible to a programmer's mistakes. During the early stage of the computer technology, it was the only available method of programming, and it very quickly revealed its serious flaws. Programming in machine language requires full knowledge of a computer hardware, design, and its internal structure. This also means that replacing the computer with one that differs in design from its predecessor can make the programmer's entire knowledge unusable. Also, the old programs could be completely useless if the new computer used a different IL. Thus, a computer written for a specific type of computer could be completely useless to other computers and vice versa. Secondly, the programs written in machine language are very difficult to understand for humans, including experienced programmers. It is also the case that to develop a program in machine language takes a lot of time and it is very costly and cumbersome. All of these circumstances lead to a need for some kind of bridge between the human's language, which is the natural language, and the computer language, which is the machine language. That bridge is also a language that an intermediate common language for both humans and computer working together. Such a language is often called a high-level programming language. A language like this is at least somewhat similar to a natural language. It uses symbols, words, and convention readable to humans. This language enables humans to express complex commands for computers. You may be asking how to persuade a computer to understand programs written in this way. Try as you might, encouraging the computer is just enough, but you can translate your program into machine language. Moreover, the translation can be done by a computer making the whole process fast and efficient. How great is that? You don't need to learn a whole bunch of different machine languages. You just need to know one high level programming language. If there is a translator designed for a specific computer, you can run your program without any problems. In other words, your programs written in the high language can be translated into any number of different machine languages and thus enable them to use on the many different computers. This is called portability. The translation we are referring to is made by a specialized computer program called a compiler. The process of translation from a high level language into machine language is called compilation. Now, let us get back to more interesting issues related to the process of creating a new program. We already know that our main task is to write a program in accordance with the rules of the chosen programming language. This program is called the source code, or simply source, while the file that contains the source is called the source file. To write the source code, you will need a text editor that allows you to manipulate text without any formatting information. This code is placed in a file and the name of the file should imply its content. For example, it is common for a file containing the source code in the C++ language to have its name ending with the suffix .cpp. So, if you write a computer program and decide to name it Progi, it would be a good idea to put the source code into a file named progi.cpp. To put the source code into a file named progi.cpp, such platform may prefer other suffixes like cc, cp, cxx, and c++, or even c. Note that this is a capital letter. Please consult your compiler documentation for details. Next, your source code needs to be compiled. To do this, you need to run an appropriate compiler and instruct it when you store the source code you want it to translate into machine language. The compiler reads your code, makes some complex analysis, and then determines whether or not you have many errors during the coding process. If you have, it will tell you. This is not to make you feel bad. These analyses are very insightful and very helpful. But remember that they are made by a machine, not a human, and you should not expect too much from them, okay? So if your mistake was not you tried to add up two numbers using hash instead of plus, the compiler will kindly inform you of your mistake. However, if you type instead of plus and the compiler cannot guess that your intention was to add two numbers rather than to subtract, the compiler will not think for you. But that's okay too. If the compiler did everything, developers would then have jobs. If the compiler does not find any mistake in your source, the result will be a file containing the program translated into machine language. That file is commonly called an executable file or exe. The name of the file depends on the compiler you use and the operating system you are working with. For example, most compilers designed for Unix or Linux system create an output file named a.out by default. Compilers designed for use in MS Windows can name the same name um, to this file as the source file while on changing the suffix from CPP to exe or exe. Of course, the whole process is actually a bit more complicated. Your source code might be huge and divided among several or even dozen of source files. It may also be that the program was not written by you alone, but by a whole team, in which case the division of the sources into multiple files is simply a must. In this case, the compiler process splits into two phases, a compilation of your source in order to translate it into machine language and a joining of your executable code with the executable code derived from the other developers into a single and unified product. The phase of gluing the different executable code is commonly known as linking, while the program that conducts the process is called a linker. What is the common use of the C++? It is the so-called object programming language, suitable mostly for large, complex applications, especially those working in graphic environments. Knowing that C++ language is very helpful if you want to learn C Sharp or C or Java. The conceptual apparatus used by the C++ language is common for the object programming language, as C++ is one of the oldest languages of that class. All right, so let's have the further readings. If you take this learning of the C++ language seriously, you will certainly not end your education with this awesome course. Among the hundreds of books written in the C++ language, there is one of we recommended in particular. The book has been issued dozens of times all around the world and is available in over 20 different languages. The book's title is simply The C++ Programming Language. It was first book it was the first book to describe the C++ language written by the language's creator, Bjorn Strostrup, and Strostrup began developing C++ in 1979 and currently, not surprisingly, is considered the most important authority in this field. You can buy the book here in this link. Okay. So another book worth reading is Thinking in C++ by Bruce Eckel. This book is available to download for free. You can find in this link. So if you like to read some of the principle in C++, you can download the PDF here in this link. So one of the recent published books that we particularly enjoy is one written by Alex Alain, called Jumping into C++. It's a great book for beginners, presenting a step-by-step guide into becoming C++ programmer. You can order the book here. So this is a paid book. Last but not the least, for those who aim to improve their programs and learn more about best practices in C++, there is a great book by Scott Mayer's effective entitled Effective C++. You can order the book here. For a more comprehensive list of good C++ book you may wish to check this thread in Stack Overflow. If you know other good books worth recommending, please free to contribute to this thread on the Facebook page. Once you're proficient programmer, you may want to have the source code through which you can quickly find the answer to emerging question or just fill in the gaps in your memory. Instead of handbook, you will want a book that briefly describes the language standards, everything that is really important and nothing more. You need what is called a report published the ISO Standardization Committee. You can find the most recent version of the standard at here in this link. But hey, it's too soon for that. Look into that when you finish this course. No sooner. Okay, guys, so we'll pause for a bit, and so that concludes the first session of the part one of the Diverse Node Mobility Front End Development Program. See you guys in the part two, and have a good day.